Okay, now we can resume the class, but before we do that, may I know if you have any question? Now the next part we are going to talk about it is the energy saving measure. Basically, when we can reduce the number of stops, or we can make the RTT, the round trip time, become smaller, etc. Actually, we can save the energy. And actually, we can have another measure. We take the energy measurements for our lift system in order to determine whether our system is efficient or not. And it is again another important benchmarking parameter for the lift system comparison. Okay, and you can collect the energy consumption of the lift through the use of the electricity energy meter. Now in the picture, we show you a meter that can be collect the energy usage for a lift system. For example, we can connect the measure for 1 week, 1 month, etc. And we can make a simple calculation for the energy consumption. And this is equal to the value. It is a unit, joule per kilogram per meter. It is equal to the total energy, electrical energy, within the time window over this number of January that we have the total weight of the passenger multiplied by the distance traveled. That actually it is the work done of the traveling. Okay. Now the input of the system should be the electrical energy of the building spent on the lift movement, lightning, ventilation, door control and display. And the output should be the transportation of the passenger, so that the work done to the transport passengers. And you can consider each lift January should be the black to black January. Okay. So that it starts at the incident when the brake is released, while the lift can accelerate and end to the incident when the brake is applied again, while the landing door are opened. Okay, and you can test different lift control algorithms in simulation software and practice, so that you can take the energy measure by comparing the energy consumption. You can use the ordinary lift system minus the energy consumption measure that you are using the lift control algorithms, such that you can make the comparison between each of the control algorithm to find the best energy saving algorithms. Okay, now the method is very simple, so I think you can easily it can easily understand, because if you can save your energy by have a lower value for the measurements, it means your system can save a lot of energy. Now, at the end of this lesson, we talk about two case studies. The first one is the gondola lift. Gondolas come from Venice. Okay, it is actually a boat, but in the building, the outlook it is look like a gondola, so we call it the gondola. Okay, it is a vertical lift. Okay, usually installed at the roof of the building, and it is used for cleaning, maintenance, and decorating in a building. Okay, and actually, using two ropes to move the lift up and down. And inside the gondola, it has a control panel to control the motion of the gondola. And actually, the gondola system has a valve so that it can move the gondola to different position of the building. Okay, it makes the horizontal movement for the gondola around the building. Now, the second system, it looks like the vertical transportation system, but it is only for a small goods. It is the material handling system, and normally it is using the pneumatic type. That means we're using a compressed air to transport the capsule. Okay, and inside the capsule, you may have some document, cash, drugs, etc. Because they are light in weight, so it can be travel through the pneumatic trip to different position of the building. Okay. So this comes to the end of the vertical transportation system, and I hope that you can, through these two lessons, you can understand the modern design in our lift control system. Okay, and immediately we will give you a tutorial, and in next week we will talk about the communication and security systems in a building. Okay. Now, but before we do that, let me remind you that we give you a new teaching schedule, okay, about the subject. Let me see. Now you can see on the screen that we are now here, okay. We just finished our vertical transportation system, and we will spend 3 weeks on the communication and security system, okay. And now on 7th of April, now we will doing a online open book in-class assignments, okay. And I will prepare some questions in Moodle so that I ask you to do it in class and submit it to Moodle after you complete it. Okay. Now the details I will give you in next week, and it is about to the vertical transportation system for the in-class assignment 1. Okay. And also we will continue our topics according to this schedule, and you may find that we have another online in-class assignment, and we will use it to test your knowledge about the communication system and also the security system. Okay, and it is arranged on 28th of April, and on that day you will have your mini project submission. Okay, remember we have a mini project that we asked you to form group on this intelligent system in a building. Okay, and on the in the last lecture on 5th of May we have the mini project presentation, and the detail we will give you later. Okay, now about the examination, because this subject belongs to the mechanical engineering or electrical engineering, that we are looking for the HKIE accreditation, and therefore we plan to have an examination for this subject, unless if the COVID-19 outbreak becomes serious. Otherwise, we will have an examination. Okay. Now the detail will be told you later. Okay. And do you get any question on the arrangement? Now, if no, we will have a tutorial with you. And in Moodle, you may have our tutorial question. Okay. So let me open it. Now it is we prepare some questions for the topics that we described last time. So you can see in question 1, now we are giving the population of a 6-story building, okay? And don't forget we have the main terminal, the ground floor, right? And we do not count for this floor. And the population is 30, 23, 54, 24, 48, etc., etc. And actually, we are going to analyze that the number of stops. And given that the morning peak period, 80% of the population arrive the building in 30 minutes, and the building has a lift capacity, has a lift with the capacity 10 person per travel. So we are using this formula to compute the probable number of stops. Okay. Now in this example, actually, we needed to find out what is the symbol. Firstly, n equal to 10. Okay. And PA, PB, PN, it means the individual population for each floor. So I can work out the calculation for the first 2 floors to you, and you may work out the other for me. Now, for example, for the floor 1, the population is 30, and because we say that only 80% of population are white, therefore you multiply by 0.8. As a result, you get it is the population is 24. Similarly, for the second floor, you multiply by 0.8, so you have the population equal to 18.4. Okay. Now, but you may say that we cannot have a 0.4 person. Therefore, you can round the data. So you can say the population is 18. Okay. And now you can make the individual calculation for this one. Now you can, after you make the calculation, okay, you can have the total population at here. Okay, and this become P. And you can make the calculation on P minus P1 over P, P minus P2 over P. Okay, and then multiply or take the power by 10 because n equal to 10. Okay, now after that, you add them and using n to minus them, n now equal to 5. And then you can get the Sn value. Okay. Now this question I left you to do as an exercise, and when you complete, you may submit it to Moodle. I will create a link to collect your solution to check whether you make it correctly. Okay. Now this is question 1. And do you get any question here? Now I will give you time to complete this question. Now I will explain to you on the question 2 first, and the question 3, so that the rest of the time you can do the practice. Now for question 2, we are giving 2 lift system A and B for the 6-story building. We have the parameters list out here. Now we have the weighted load. Okay, 12 and 18, speed 2 to 1.5, probable number of stops 4.2 and 5.5. 5.5. Now we can refer to the symbol that we use in our logs. Speed means V. Probable number of stops is S. n. The accelerating distance is d. For A, it is 2, B is 1.5. Distance between ground and top floor, it is capital letter D. Both of them are 30. The total door open and closing time, okay? And also we have the total passenger entering and leaving time, okay? And the number of lifts for both systems. Lift A, we have 4 lifts. System B, we have 3 lifts, okay? And assume 10% margin will be considered in the RRT. Now this is RRT, round trip time. And the car load factor is 0.8. And we are going to find the following for both systems. Now I will illustrate to you for system A, and I will ask you to, this is RTT, sorry. And I will ask you to practice the calculation for system B. Now for the total traveling time, according to our notes, you can find the formula. It is equal to 2 over V times D Sn plus 1 plus D. Okay? And by using the value that we list in the table for A, we can find the total traveling time. It is around 40.4. That means that how can we achieve this answer? You can have now Sn plus 1, you have 4.2 plus 1 times D is 2, plus 30, and then multiply by 2 over V. V is 2 here. So you can make this answer equal to 40.4. Okay. And the total round trip time, you are going to calculate this value with the door open and closing time and the passenger entering and leaving time. So by adding these 3 values, and you have the RTT equal to 83.4. But we should consider the 10% margin to the RTT. So you multiply by 1.1, and you get this one become 91.74 seconds. Part C, the number of trips per 30 minutes. In 30 minutes, you have altogether 1,800 seconds. So you're using this value dividing by RTT, and it becomes the number of trips per 30 minutes. Okay? Because in 1,800 seconds, you can count the number of round trip for the lift. So after you make the calculation, it becomes 19. Now you may have a decimal number for this value, but because the trip should be an integer, therefore you truncate the decimal part, so it becomes a 19 trips. Okay. Now the handling capacity now remains a 5 minutes handling capacity. Therefore, you apply the formula that you have 4 lifts multiplied by 0.8, the car load factor. The weighted load is 12 times 300 over RTT. This one, you have the handling capacity equal to 125. Again, we take the integer part only. And the waiting time, you are using the ROTT dividing by the number of leaves, so that you have 91.74 dividing by 4, and it is equal to 22.9 seconds. This is the waiting time. And finally, the grade of surface. In the logs, we have the equation, the waiting time, Wi over 4 times 2 plus n, where n is the number of leaves. So applying the formula, you can get the grade of surface equal to 34.35. Okay? Now, you can make the similar calculation for system B, and you can get another grade of surface. After that, you can compare the leaf system to see which leaf system gives you the best result. Okay? And again, I will, after you complete the calculation for leaf system B, you can upload to Moodle, and later I will check it to see whether you give the correct answer or not. Okay? Now we come to the, do you have any question? Okay, I found the question how to calculate 83.4. This one actually come from 40.4 at 18 at 25. So you have 40.4 plus 18 plus 25. This is the total time together with the door opening time, door closing time, the passenger entering time and leaving time. Okay? Any more questions? And now we come to question 3, and actually it is a similar question that we are going to make the analysis for the peak analysis. Okay. Now we say that we have a building with 24 floors. Okay. Including the main terminal. That means above the ground floor we have 23 floors. And we have the following lift traffic. Now we assume it is a balanced population, each floor occupied by 100 persons, and the total travel for the lift, that means from the ground floor to the roof, it is 75.9, and each floor to floor 5 is equal to 3.3 meters. The passenger transfer time, this is 1.2 seconds. Door opening time, 0.8 seconds. Door closing time, 3 seconds. The speed of the lift, contract speed, 3.5 millisecond. Meter per second. And single floor flight time is 4 seconds. The number of lift car is 7. The capacity of car lift is 20, and the car load factor is 0.8. And we are going to perform the 5 minutes up peak analysis for average up peak interval and the percentage of the building population transported. Okay. Now, if you refer to the logs, we make an example also to help you to make the calculation. At that time, we give you some equation to calculate what is H and what is S. But in practice, the calculation of H and S may be relies on some tables. Therefore, in this tutorial, we give you a table to help you to quickly obtain the value of H and S. Now, according to the information provided by the question, the building is 24. Okay, it has 24 floors. Okay. Let me check it. Okay, but above the main terminal, we have 24 only. Therefore, in this table, we identify the role for 23. It means we are going to obtain the value of H and S for 23.4. And now the population the car population, actually, the capacity is 20, but we have the car load factor by 0.8. That means you are going to multiply 20 by 0.8, and it is equal to 16. Therefore, we identify the population for 20 to 6, so that we have the car load factor by 16. Okay, so the corresponding H is 22.1 and S equal to 11.7. Okay, and now if we are going to apply the what we call the upbeat analysis, we relies on first calculate the one. Okay, we are going to first calculate the RTT. The equation provided to you is equal to 2 times 2h times TV plus S plus 1 TS plus 2P TP. Now, they are the time that it is the normal traveling, the stop, and the passenger leaving and entering time. Okay, so now in the data we provide to you, you needed to find what is TV, TS, and TP. Okay, so in here you can see that TV can be using the speed. Okay, this is the speed. Over the single four distance. Okay, and the TS equal to the single four flight time TFL minus TV, where you have calculated in here, plus the door opening time, also the door closing time. Okay, and TP, actually the transfer time already given to you, it is TP. So now you are going to make the calculation on TV and TS and then plug into the formula that I provide you to here, and then you can get RTT. And after you get RTT, now you can make the calculation for the up interval UP PINT. That means the number of trips you can travel using RTT over the number of lift car. And the number of lift car is 7. Okay. So this answer will become this one, the average upbeat interval. Okay. Now, after you do that, you are going to calculate the percent of building population. So you first calculate the upheat capacity, UPPHC. We have the formula that equal to 300 times CC, where CC is 16, times the number of lift car over RTT. Okay. Now this is a value that tells you within 5 limits how many passenger can be served. Okay, and it should be an integer, so that if you get a decimal number, you can truncate the decimal part. Okay, and then after you calculate PHC, you can find the percent population by using the formula UPPHC times 100 over the total population. Now the total population, because we have 23 floors and each floor has 100,000, 100 persons, therefore you have 23 times 100 here. Okay, then you can have the percent population. Okay. Now I don't make the calculation for you, so that I ask you to make the calculation by yourself. And again, after you complete the calculation, you can upload it to Moodle, so that I can check it to see whether you get the correct answer or not. Okay. And do you have any question? Now for the rest of the time, you can practice the questions that are given to you. And now I'm going to make the Moodle link for you for your submission, so that if you can yeah, I make a mistake here. So someone has told me for the TV, yes, we have reversed the symbol. It should be D over V. I'm sorry for that. So please make the correction. Okay. Now again, after you complete the calculation, please submit it to Moodle and I can check it for you. Okay. If you have any question, you can ask me, and we still get some time.